So, today our learning intention is to learn about the forces on the inclined plane. So, if we have some object and I put it on the inclined plane, which is inclined at the angle to the horizontal, and it's not moving now, then increasing angle it starts moving. Which forces are acting?
Friction and
gravity. So this is the inclined plane. This angle is theta. We have object here, this mass. We have gravitational force or weight force, mg. What else acting?
Normal.
We have normal reaction, which is at right angle to the surface. And we have, in this case, we have friction. So, when you're solving problem with the forces, we need to start from the diagram, which we did. Second step, label forces. We label all forces. Now we need to choose axis. If it will accelerate, in which direction it will accelerate? Accelerate. Down the plane. So, most convenient to choose one axis down the inclined plane, and one we choose perpendicular to it, y. And let's write the resolution of the second Newton's law first into the x-axis. But to do that first, we need to find the resolution of the mg into the inclined plane, because n is completely along y-axis, friction force completely along x-axis. Just force of gravity act on both. So to find resolution, we draw perpendicular, and that will be mg, force of gravity in the x direction. It's not new force, it's just part of this force acting along x. What it will be equal, if this is mg, this is angle theta. In this triangle, where will be angle theta?
In the top right.
This one. If this theta, then what will be this angle? You make right angle triangle, this will be 90 minus theta. If this is 90 minus theta, this angle will be theta. Then what fgx will be equal?
Sine theta.
mg times sine theta. Sine theta. So component of the gravity acting down inclined plane, always mg sine theta. What are the components of the gravity acting perpendicular to the inclined plane?
mg cos theta.
mg cos theta. Now we can write second Newton's law in resolution into this axis. So, into x-axis. What do we put into the x-axis? We have in the positive direction, we have mg sine theta minus friction force equals ma. This is the net force acting along x-axis, mg sine theta minus friction force equals ma. In the y direction, we will get normal reaction minus mg cos theta equals 0, because there is no acceleration perpendicular to the plane. It's not jumping out of the plane or digging to the plane, so that what it will be. So from here we get normal reaction if we need to find one, mg cos theta. And from here we can find what we will be looking for. If you know friction force, we can find acceleration. By the way, if the surface is smooth, so friction force equals 0, this equation becomes mg sine theta equals ma. Mass cancels out, and we got on the smooth surface acceleration equal g sine theta, which you can use straight away. If the plane is smooth, acceleration will be equal g sine theta.
Is it beneficial to derive these formulas every time, or should we just memorize these?
You just need to know that the component of the gravitational force along the inclined plane is mg sine theta. And then you draw a diagram, label forces, and you resolve forces into the components. Now, let's consider a simple example. Mass is, let's say, 10 kilograms. It starts at the distance of 3 meters from the bottom of the plane, angle theta equal 30 degrees. We have friction force equal 5 newtons. And to make calculations easier, let's take G approximate as 10 meters per second squared. Question is how long it will take the block to slide to the bottom of the plane. First, we need to find acceleration using the equation in the x direction. So we will have mg sine theta, which is 10, mass 10. We have 10 times 10 times sine 30 degrees, minus friction force, which is 5 newtons, equal 10 times acceleration. So we have this will be equals 10, because sine 30 is 1/2. 10 minus 5 equals 10a. So we get a equal 0.5 meters per second squared, because 5 divided by 10 is equal 0.5. That will be acceleration. How we can find now time? So what equation? We have initial velocity, it starts from rest. We have distance s equals 3 meters. We have acceleration equals 0.5, and we're looking for time. So we're using formula. Which formula are we using? S equals ut plus 80 squared on 2. We have 3 equals 0.5 t squared divided by 2. So we'll have t squared equals 12. So time will be equal square root of 12, will be approximately 3.4 seconds. You can check this. Probably 3.45 seconds, I guess. Can you please check with the calculator? Square root of 12.
3.46.
3.46.
Insane.
Okay, makes sense what we did?
Yep.
Now I will make question hard. I will now push this block up the plane. So it goes up and then slides down.
Wow.
Let's find when I push it, does my force continue to act on it when it's sliding? No. What I do, I just give it initial velocity. So we will have and question is, if I'll give it initial velocity 10 meters per second, and we have friction force, the mass of the block equal to, let's say, 2 kilograms, mass equal 2 kilograms. We have theta equal 30 degrees. Again, G we take 10 for simplicity's sake. We have, and I give it initial velocity equal 10 meters per second, 5 meters per second. Question is how long it will take block to get back to the bottom of the plane.
What about friction?
Friction force, let's say 2 newtons. Question is find time, how long it takes block to go up and return back.
It starts at the bottom, right?
Starts at the bottom. First, when it's moving up, let's again label the forces, because we have energy down, normal reaction still there, but what will be the direction of the friction force when it's sliding up?
Down.
Down. Friction force will be down. And the resolution of the forces into the x-axis will be mg sine theta plus friction force, because they both acting in the same direction, equals ma. So let's find its acceleration.
Well, mg sine theta. Oh yeah, true. Right, yeah.
It's always mg sine theta in the inclined plane. So we have 2 times 10 times sine 30 degrees plus 2 equal 2a. So we have, this will be 10 plus 2, we have 12 equal to a. Acceleration is 6 meters per second squared down the plane.
Do you not take into account the force of initial, like,
Initially, all I do, I give it initial velocity. So let's find how far it will move up the plane. Using Sulat, we have u equal 10. Final velocity is 0 because it stops momentarily before sliding down. We have acceleration equals 6.
Why is u10?
Hmm?
Why is
Because I spoke 5. My bad. I said 5. Yes. U equals 5. Acceleration equals 6. Final 0, and we're looking how far it moves up the plane and how long it will take it to get up. To find time, we're just using v equal u plus at, which becomes 0 equal 5 minus 6t. So times equal 5 over 6 second. Let's leave it as a fraction.
Well, so a equals to 6, negative 6.
Because acceleration down the plane, initial velocity is up. It's moving up but slowing down initially.
Okay.
And find s, we can use v squared equals u squared plus 2as. We get 0 equal 5 squared minus 2 times 6s. So we get 12s equal 25, and it will go up to 25 and 12 meters. That's how far it will move up. But now when it will go down, the equation, so we'll keep this time and we can keep this distance. But now situation will change. When it's will be sliding down, we will have now the friction force will be up the plane because it's sliding down. So we will have the equation will slightly change. We'll have mg sine theta minus friction forces. Acceleration will be different. So we have minus 2 here equals still 2a. So we have 8 equal to a, 8 equal to a, and acceleration is 4 meters per second squared. But now we're looking for time, how long it will take to get down. Now we have initial velocity 0. We now know the distance is 25 and 12. 25 and 12 meters. We know acceleration equal, how it's 2 when it's 4. 8 divided by 2 is 4. Acceleration equals 4. And we need to find time. Again using S equals ut plus at squared. We get 25 on 12 equals 4t squared on 2. So we get 2, so 25 over 24 equals t squared. So t will be equal, we can calculate t will be square root, will be 5 on root of 24, just 6, so yeah, can you?
5 over 2 root 6.
Yeah.
It's very interesting. 1.25. 1.02. Ah!
1.02 seconds. Now, can we divide this?
Oh,
5 divided by 6 will be about 0.83, I think. 0.83 seconds. So total time up and down will be this time plus that time, 1.02 plus 0.83 will be equal 1.85 seconds. Make sense what we did?
Yep.
Okay, that's how we're dealing with the forces on the inclined plane. Like, subscribe and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, Hezbollah and so on. Support Ukraine and Israel.